today I'm going to make this quick video, we'll see if it's quick, to describe some of the angle relationships that you missed while you were gone. They relate to triangles and then to lines that are parallel or not parallel. The relationships, I think some of them will be familiar and some of them are not that complicated, but what everyone seemed to have struggled with was the academic vocabulary and all the math words that you need to know that go with this stuff. So let's just kind of kick this off. My pen doesn't work really well all the time, so hopefully I can do it without having to stutter too much. So see what I mean? So the first thing that we talked about in class was how when you have a triangle, whether that triangle, hold on a second, whether it be like a really tiny triangle or have huge angles or angles that are all kinds of sizes, no matter what, when you add up the angles together in any triangle, it always equals 180 degrees. So if I took this angle measure and this angle measure and this angle measure, it'd be 180 degrees. If I took this angle measure and this angle measure and this angle measure, it'd be 180 degrees. And when you look through the notes, there are little activities to help you believe that fact, but I think a lot of kids learn that when they were in elementary school and remember that idea of angles always adding up to 180. Now, one of the consequences of that happening is a kind of a newer theorem that we have. So sometimes you're going to see a triangle like this, or like any triangle really, and we're going to extend one of these lines super duper long, super far away. And we're going to talk about these angles all being on the inside. So these are all considered interior angles. And when I extend a line out, like if I let this line go straight across, this guy here is called an exterior angle. And you're going to see a theorem that we're going to prove and use that says basically that this purple angle is going to equal the sum of these two angles that are remote on the inside and remote, like far away, like a remote location. We prove it. The idea would be that, I don't really necessarily know what this is or what this is, but I do know that anytime we have a straight line, and we have an angle off that straight line, and actually this might be news to you, or you might have heard this, but if you heard this a long time ago, if you have two angles that are together and they form a straight line, these also add up to make 180 degrees. So for example, if this is a straight line, and this is 150 degrees, then this would have to be 30 degrees, because together these have to make 180. On another example, if it's maybe more like this, and maybe this guy's like 70 degrees, but this is a straight line, then this is whatever's left of 180. So that'd be 110 degrees. So we have something going on here. We have a situation where these two angles, x and y, since they form a straight angle, they're going to definitely add up and make 180, no matter what. And let's put some other letters down here. This is y. Let's call this w. Let's call this z. Since these are all inside of a triangle, we also would know that w plus z plus y also equals 180 degrees. And basically, since this is 180 and these are 180, I can set these guys equal to each other, since they're both 180. If that makes sense. Chew on that for a second. So if x plus y is 180, and x plus y plus z is also 180. I'm sorry, not x plus y plus z. That's not what I meant to write down. I meant to write down w plus z plus y is also 180. Well, we don't need this y on here twice. I can subtract this y off of both sides, and I get x, this angle on the outside, is equal to the sum of these remote interior angles. Now the way we use this in class is to say something like, hey, I want to know what this angle measurement is, and I'll tell you that this one's 30 and this one's, say, 90. And from that you should be able to figure this out. Now there's a couple ways kids might go about doing this. Some kids might use the fact that angles add up to 180 to figure out what this angle is, and then once they figure that out, subtract it to find out x. But if you know this little shortcut, you can say, oh, this angle here is equal to the sum of these guys over here. So x is going to equal whatever 90 plus 30 ends up being. So you'll see that taught in the notes as well. So that was kind of like day one. Triangles sum up to 180, straight angles sum up to 180, and then this exterior angle equals the remote interior angles. You'll see that in the notes. The next part that we talked about, you missed, had to do with what happens when we have a line and another line that's exactly parallel so that these don't ever cross, and we have another line that cuts across them. Let's make that a different color actually just for a second. So that if these purple lines, if I as your teacher want you to know that those lines never ever cross, the word you might remember from your earlier days is that they're parallel. Let's write that in the same color as the parallel lines. I always liked the word parallel because it had two L's in it, so it kind of like gave you a hint of what the word meant. And if in a picture I want to indicate that they're parallel, I'll put these little tiny arrows on it to indicate that they're kind of like going the same way and they'll never cross. That pink line that cuts across is called the transversal. Like transverses, goes across them. And you could have multiple transversals if you want to. You know, you could have another transversal that comes across like this. That would also be considered a transversal. I don't want to muddy up the picture right now, so I'll take that transversal away. You just could have multiple ones. Well, I don't know if you were here the day we did this thing with the cow map. One second, let me grab something. So there was a day in class where we looked at a map like this. You can see how this is supposed to look like a road map. And there's roads that are parallel and roads that cross each other. And we put all these angle measurements in here. And I want these purple and pink lines to kind of remind you of that road map a little bit. So think of that pink line as a street that cuts across two purple streets, and those purple streets don't ever meet each other, you know? A funny thing happens. If I know that these purple lines never, ever, ever, ever meet, ever, but the pink line cuts across them, then I know a few other things. Like if I know, for instance, that this is, say, a 65-degree angle, and if this, think of this as an intersection of a street now. So if this intersection here, where the pink and the purple line cross, is basically identical to this intersection over here, because the purple lines, of course, are going in the exact same direction, and the pink line, of course, only goes in one direction, they'll be identical, then we would know actually a lot of things. Like basically every angle, this angle here, angle 1, angle 2, angle 3, angle 4, angle 5, 6, and 7, just by giving that 165-degree angle, if the lines are parallel, I can figure out every other angle on that page. Because as soon as I get this, let's make this box not yellow, but orange. As soon as I get this orange box figured out, since the yellow box is basically the identical intersection, it'll have all the exact same angle measurements going on. And this is where, like, we have a lot of vocabulary because there's lots of ways to compare angles. But the math, I hope, is not too bad. So here are some words that we're going to use. One of the words we're going to use frequently is the word linear. It means line, pair. Two angles can form a linear pair if they make a straight line. So for example, you see angle 1 here and angle 2, how angle 1 and 2 up together, like if I just focus on that part, you have the pink line that goes like this and the purple line that comes across like this, and this is 1 and this is 2. So there's this angle, and together they make this straight line. So 1 and 2 are considered linear pairs. 2 and 3 are considered linear pairs. So whatever. 4 and 5 are linear pairs. Maybe think of another set of linear pairs for a moment. So maybe you were thinking 4 and 6 are a linear pair. 6 and 7 are a linear pair. 7 and 5 are a linear pair. There's a lot, like those, they have to be like basically right next to each other and make a straight line. If they make a straight line, we know they add up to 180. So because 1 and 3 are linear pairs, I can figure out that this is whatever's left of 180 once I take away 65. My mental math is not that great all the time. And in a video, I don't want to make any silly math mistakes, so I am going to break out a calculator. Even though I can say 180 minus 60 is 1. Okay, so it would be 115. I can do it in my head. That would be 115. But there's more. Because 1 and 2 are also linear pairs, so angle 2 paired with angle 1 together should make 180. And I basically just did this calculation, but like obviously if this is 115, if 115 and 65 together make 180, and I have the 115, then this is obviously going to be 65. And this will also be 115. And that would be that whole intersection. We have all those great linear pairs. And then that entire intersection could like be slid down. Let me see if I can do this. Check this out. Is this going to work if I go like this and like this? Like the idea is we're just going to take that and slide it down. It's not working out as cool. Oh, let me do this. Paste that in there, bro. Nice. So I'm saying like this whole piece could be slid right down to here, and they're identical. They're identical. So now I know all these other angle measurements as well. All of them. Get that out of there. Beep. Oh, ding, ding. Okay. So just from having got the intersection figured out, I know that this is 65 degrees. I'm going to use a different color for every angle this time because I got to emphasize some vocabulary. That's 115. That's 65. I want to make that 115 a little cleaner. That was a weird face I just made. And then this is 115 as well. Okay. Done. But what I want you to notice is every angle in this picture, for any two angles we look at, those two angles are either congruent, meaning they have the same measure, or they are supplementary, meaning they add up to make 180. And there's all kinds of words we use to describe them. You can really drive yourself crazy trying to figure it all out. So we're going to do that on a clean screen in just a few moments. But that's the gist of what you missed. Now, I want to also point out, this only works if the lines are parallel. So one of the questions we like to ask is we say, okay, if they're parallel, this is definitely true. If the angles that are down in this area don't match the ones that are up here in the same way, then the lines are definitely not parallel. They're not parallel. So sometimes what we might do is get rid of these little arrows and say, yeah, these lines are parallel. We'll get rid of that. And we might give you a picture like this, except we won't give you all this picture. Maybe I'll just give you, like, that 65 degrees there, and maybe I'll give you the pink 65. And I'll ask you the question, are they parallel? And then you have a lot of thinking to do. But at the end of the day, it's like, oh, if I slid this thing down here, they should both be 65. If they both match, then they are parallel. But if this measure here, instead of 65, if it was marked as something else, if I like gave it to you as like, say, 63 degrees, then you would say the purple lines are not parallel. And then I'd be like, why? Justify it. Tell me how you know. And this is where all the vocabulary is going to come in. The slideshow goes through it. But I want to clarify a couple ideas. But I might do that in a separate video. So that's good for now on this, and let's try a separate video so that you're not, I don't know, just because you might want to look at this separate video later on and not watch this first 13 minutes all over again.